Hello everyone and welcome to Unitronics webinar. My name is Ophir Levy and I'm the head of the technical support in Unitronics. And today's webinar is about our new product VFD. Okay, so in keeping with our commitment to centralize and streamline industrial automation and control, we are happy to announce the release of our new product, the Variable Frequency Drive, also called VFD. We can find the need for VFD almost in any application such as filling machines, compressors, HVAC, conveyors, food packaging, and much more. Now we have a complete solution both for control and automation. So as you can see, we have already complete range of PLC plus HMI, all-in-one software, outstanding support, and now even full range of VFDs. In one software environment, we can program now the control code, let's say the ladder diagram, design the HMI screen, and configure and control the VFDs. So as we can see in the picture, with Unilogic, for example, we can program the Unistream to configure the Unitronics VFDs and of course control the VFDs, which will be probably connected to some motors, pumps, and so on. Some features of our VFDs. First of all, as I mentioned, you will see later in this webinar how easy to program and simple to use. They have EMC built-in filters. Of course, every place that you see the asterisk, this is a model dependent. We have several mounting options like wall with a flange, DIN rail. Okay, the temperature environment can range between -10 to +50, supporting Modbus RTU. Braking units, which are built in. Of course, as you know, we are not using the VFD for emergency stop. In case you need emergency stop, you will have to install a mechanical brake. Supporting sensorless vector and torque control. We have a heavy-duty overload capacity. We'll see it in a moment in the specifications. STO, safe torque off, and even remote access via our Unilogic and VNC to the PLC, which will be connected, of course, to the VFD. Let's see the specifications. So you can see that we have several models. UMI, by the way, is for Unitronics motion inverters. We have the B1EU, B1UL, and B5UL. So you can see that we have, you will see in a moment, the certifications both for CE, TUV, and SUD, and also for the US market, the UL. You can see here the input voltage, supporting different types of input voltage with single phase and three phase. Input frequency 50 to 60. For the B1 models, the supported motors will be as asynchronous induction motors, three phase. And for the B5 model, supporting also permanent magnet synchronous motors. The output frequency will be 0 to 400 Hertz. And the overload capacity, as we discussed before, can be up to 60 seconds in 150%, in 180% up to 10 seconds, and in 200% for 1 second. Under the control, as we mentioned before, we're supporting space vector, PWM, sensorless vector, and We can control the VFD via Modbus, analog input or digital input, PID, and even high-speed input. The communication will be over Modbus RTU 485. Number of inputs and outputs, we can see under analog inputs, depending again on the model, we have supporting 0 to 10 volts or 0 to 20 milliamperes, and digital inputs supporting here 4 or 8 normal digital inputs and 1 high speed. Also supporting analog outputs and digital outputs and relay outputs. As you can see, for analog we have again 0 to 10 volt and 0 to 20 milliamperes depending on model. And for digital outputs, in the B1 model we have 1 transistor output, and in the B5 we have 2 transistors actually, which one of them is high speed up to 50 kilohertz. And supporting also relay, again the amount of relays depending on the model. Also there is a dynamic braking unit depending on the size of the unit. So you can see that below 37 for the B1, below 37 kilowatt, it has a built-in, and above it it's optional, and of course later on we'll see the accessories where you can buy the braking resistors. For the B5, as you can see, under 30 kilowatt we have them built in, and above it again optional for purchasing. EMC filters as well. Above 4 kilowatt it's a built-in C3, and below you can purchase it, the filter C3 also from our accessory list. The temperature, which we already discussed, -10 to +50. The enclosure rating is IP20. The mounting option, as I mentioned, depending on the model, wall and DIN rail or flange. The VFD are cooled by a fan, air cooling, and as you can see, the B1 EU supporting the safe torque off, the STO, and you can see also the compliance, the CTUV SUD, the safety mark, and for the ULCE, UL and CUL. Let's take a look on the product designation. So as you can see here, this is the part number for the VFDs. So the first part is UMI, Unitronics motion inverters. The second one is the power range. So for example, you can see here, let's say 0004 is 400 watt, 0022 it's 2.2 kilowatt, and so on. The number 3 is the power rating. So B, it means one phase, 200 volts. C is 3 phase, 200 volts, and E is 3 phase, 380 to 480 volts. The fourth one, which is the certification, the U is for UL and E is for TUV and SUD. And the last one, 5, is the product series, whether B1 or B5, which we saw before in the specification, the differences. So if we take a look here on the product, this is again one of them. We have several different. The B5 looks of course different, but in general we have the keypad for controlling and configuring if one wants to do it from the keypad. We'll see it in a moment. We have here the option to connect external keypad, so you just open this and you can connect, if you buy from our accessories, the cable and the external keypad, you can connect it here. The analog potentiometer for changing the frequency if one wants to use it. And here we have the upper cover, which is a dual layer to expose the terminal blocks for connecting digital, analog, and so on, and also connecting the power and the motor. Okay, we're supporting, as we mentioned, wall mounting or DIN rail, as you can see here in these examples. You can also connect them here, as you can see, on a DIN rail, one after the other. In case of installing one on top of the other, there is an option to tear off the protective film for the ventilation. Okay, and also here we have the option for the bottom heat releasing grid. Okay, so in terms of accessories, we support here external keypad, as we mentioned, flange mounting, braking resistors, filters for C3 and C2, and dam board side for heat releasing holes. Now, let me just double check if there are any questions so far. In general, at the end of the webinar, I will give time for questions. Okay, I see that there is no question for now, so let's continue. Okay, so just in general, the safety, of course, when you take out the VFD from the box, one must read all the safety and precautions. In general, I just want to mention that VFD is the first Unitronics product that involve high voltage grid. You will see also it is mentioned in the manual that after turning off the VFD, you can still not touch all the area of the power. It's very dangerous because the VFD has the DC capacitors, which is it takes time for them to discharge for at least 5 minutes. Okay, and like I mentioned before, the inverter cannot be used for emergency stop device. We must install a mechanical brake. Okay, in terms of the wiring, we can see here in this area, the yellow area, of course, safety. So here, the RST is for connecting the three-phase input from the grid. Of course, we have, as I mentioned before, we have also one phase, so you will see here LN. UVW is for connecting the three-phase to the motor, and of course the grounding and protective earth. By the way, if I didn't say, but this is by the way the terminal. So here, for example, S1 to S4, these are the digital inputs. HDI is the high-speed input. Y1 is the transistor output. Analog input 2 and analog input 3. If you are asking what is analog input 1, basically it's linked to the potentiometer here. The relay outputs, the VFD has also 24 volts built in. So in case you see here the jumper is connected this way, the inputs will be as NPN. If you want to work with the PNP, you just need to move the jumper between the power and the COM. Of course, these two COMs are internally connected. And we have here the ground, the analog outputs, and the 485 minus plus connection. For the EU, we can see that we have here in the terminal the STO terminal. So here we can connect the inputs for the safe torque off. We can see also here it in the diagram. Okay, and of course the STO is mostly used for safety. It helps to prevent unexpected start of the motor and also to cut the drive signal in cases, of course, where human is working next to the motion devices. And let's say when he is crossing some area, we want, of course, to stop immediately the motor. So this is the purpose of the STO, which is seal 2 and 3. Here we can see in the diagram how to connect the safe torque off. Of course, all these diagrams and pictures were taken from the manual, and in our website under the new page VFD you can find all this information. So let's talk a little bit about the keypad. This is an example for keypad which we can take out from the VFD. There are models where the keypad, the lower models, let's call them, the one with the low kilowatts, usually will have the keypad as a built-in, as we saw before, and the more you go up, the keypad can be taken out from the inverter. If we are talking about operating using the keypad, so here using this key, the program and escape, here we can select by pressing on it the program number, and using, of course, here the enter key, we can change the parameters using the up and down arrows, and also using the shift we can move between the digits when we want to change the higher numbers of the parameters. Run and stop if we are going to control the VFD from the keypad, and also option for jogging via the keypad. Now in the next slide we'll see several examples for configuration. In general, as you know, when you are using VFD, the first thing you need to do first is to configure the motor parameters. The motor parameters will be in group number 2. You can see that the parameters are split into group and to the index. Okay, so let's say this is group number 2, and here we need to configure the motor power, frequency, speed, voltage, and current. As you know, on the motors you will have a plate, and on the plate you can find all this information, all these 5 parameters, and you need to basically set them in order for the inverter to move the motor in the best performance. And here these 2 parameters, 0001 is the run command source. The source of the run command, meaning to start the drive, can be from keypad, it can be from terminal, from the digital inputs, and it can be also by communication by Modbus. We can see here in this parameter 0015, we can activate the auto tune. We can see it here. There are 2 types, actually 3 types of auto tuning. The first one, which is called rotation. Rotation auto tune means that we are performing auto tune when the motor is not connected to the load, which is recommended. If we are not able to disconnect the load from the motor, we will use the option for static auto tuning. Here, this is an example how to configure the parameters to perform jogging via the keypad. So these 3 parameters just define what will be the jog frequency, what will be the acceleration and deceleration of the jogging, and how I want to perform the jog, and this time is from the keypad. Here we can see again just an example of the terminal. If we want to control the VFD via the terminal block, via the inputs, for example, the digital and analog inputs. This is an example of 2-wire control mode to control the VFD via digital inputs. So we can see here that we can configure the S1, which is the terminal for input number 1. We can configure it to perform forward, so that means that when I will apply 24 volts or 0, depending on PNP and NPN on this input, the motor will start running forward, and I can do the same for S2, which is terminal number 2, for reverse, and the mode, which will be if I want to use 2-wire control, and then I can use this method. You can see also jogging via the I/O terminal. So again, you can configure again the S1 this time to perform the jogging. I can just show you, let's say in the user manual, you can see here, this is how to configure the digital inputs, for example. So you see number 1 is forward, number 2 is reverse, and so on and so on, jogging, fault reset, and you have here many options of configuring each one of the inputs, what it will do. Again, this depends on the application. You can do it, of course, also everything you can be done also by communication if you want if you don't want to use the terminal. This is another option of a 3-wire control mode. This is an option to set the frequency source via an analog input, let's say analog input number 2. So instead of, let's say, setting the frequency by Modbus, let's say, if you want to do it by analog input, then no problem. You can just set parameter 006, which determines what will be the frequency command source. Number 2 means analog input number 2. Again, if I will go back to the manual, you can see if I will go to program 006, yeah, so you can see here, this is the definition. So 1 is analog input number 1, which is the potentiometer, and 2 means analog input number 2, 3 number 3, and 4 is the high speed, 5 it's a simple PLC program if you want to do it again by the digital inputs, 6 is the multi-step speed, and so on and so on. So there are several ways to set what will be the source of the frequency. We can also configure the outputs of the VFD. So here, for example, the relay output is configured to show fault. So for example, whenever the VFD goes into fault, the relay output will be on. And then let's say if you want to put some tower light on the machine to show that right now there is a fault in the VFD so everyone can see it in the factory. In the PDF, in the user manual, you can also find all the fault diagnostics. So in case the VFD goes into fault, you can see here the fault code, which will appear on the screen of the VFD, and we can find what is the possible cause and what can be the solutions. Okay, so these are the fault diagnostics. And so this is an addition from Unitronics to allow OEMs to simplify and centralize their control needs, relying on fewer components from fewer vendors. They now can save time, budget, and efforts with this all-in-one approach. So as you will be able to see in a moment, also when we will review the software, you can see how everything can be programmed in one environment. So let's now jump directly to Unilogic. Okay, so I just opened a new application. In a moment I will also open some example applications. We already published in our support portal examples and some information about the VFDs. Also, as I mentioned, in the website, you can find the user manuals and all the marketing information. Now, when we open a new application in Unilogic, we have a new section under the hardware configuration, which is called Motion. Under the Motion, we have VFD, and here you can find VFDs and configuration. So first of all, when I go to VFDs, here in the toolbox, I can find the families, okay? So for example, let's say I will pick one of these. So let's say I will take this one. Again, on the VFD, you will have a sticker with the model. So by double click or by drag and drop, we can add the VFDs. The communication channel in our PLCs will be the port on the CPU, or if we are referring to Unistream 5, it will be one of the RS485 ports that you install. So in communication channel now, we have to define where the VFD will be connected. So I will go first to PLC communication physical, serial COM. And under the serial COM here, I will first check the VFD. By default, the baud rate is 19208 even 1. This is done because when you take out the VFD from the box, this is the default settings. If you want to change it, of course, you can change it via program number 14 in the VFD. So you can select here the baud rate, parity, data bits, and so on according to what you configured in the VFD. Now if I'm back here, I can select here the communication channel for each one of the VFDs. Here we can set the ID, the Modbus ID. Of course, Modbus ID can be determined also in, I can just really quick show you. If we go to program number 14, okay, so in 14.0, this is the slave ID, and 14.1 the baud rate, and 14.2 this is the parity, and so on. Start bit, stop bit, and so on. Okay, so once we configure the VFDs, now the next stage is to create the configuration. So we go to the configuration, and here we need to pick the model. So in my case, I will pick, for example, the model 1.5 kilowatts. Okay, again by double click or by drag and drop. So we can see here the model, and we can see here the configuration. Here we can determine the configuration of the VFD. So if I will click on it, I will get this grid. Let's take a look on the grid. You can find in the grid the function code, same it appears in the keypad, the name, the configured value. Okay, so here we can determine the value that we want to configure for each one of the parameters, minimum and maximum, and the default value, and of course units. Here on the left, you can see all the groups. We added the for your convenient, two groups which are called fast or modified. Let's see what does it mean. The fast, we collected the most common parameters which are used, which are including, for example, the speed control mode, the run control mode, the frequency, maximum frequency, upper and lower limit, acceleration, deceleration, jogging, and so on. Then later on, if you go to each one of the groups, you can define here, let's just take an example. Let's say I want to configure here my speed control mode to vector frequency control. I want that the run command channel will be by communication. and let's say the maximum frequency will be, let's say, 60, for example. Okay, each parameter that I'm going to change will appear immediately under the modified parameters. If I want to restore all the configuration back to default, I can just right-click on the configuration and select Restore to Default. You can see that we have also the option to duplicate the configuration, export it to file, and even later on to import the file back to Unilogic. Okay, once you finish to configure all these parameters, we are ready to take a look on the struct. So you can see under the IO tab, we have here the option for the structs. So the system automatically creates a struct per VFD. Let's open it just to take a look what we have in the struct. So under the struct, we have a bit to enable the communication. Once it's, we will set it on, we are starting to communicate with the VFD. Indication whether the VFD is connected or not. If the bit will be on, then we have communication. If it's off, we need to check the wiring, baud rate, and all this information. Enable periodic status read. This is a bit that once we turn it on, it will start reading automatically all the statuses from the VFD, and you can see all the statuses under the array status. So here, as you can see the status, if I will open it, you can find here, okay, what is the output frequency, what is the output voltage, what is the output current, speed, and many parameters can be found here. The statuses, not parameters, can be found here. So you don't need to do anything by letter. You just need to turn on this bit to enable the read, and all the information will come into this array. Okay, you will see in a moment the current configuration name. Basically, we can load the configuration to the VFD. The configuration, again, that we prepare here, we can load it to the VFD, and according to the name of the configuration that was loaded to the VFD, we can see it here. We can see the line and model, and we have all the rest of the parameters as an arrays inside the struct. So for example, you can see the basic function group here. We can find also everything here under the array. Okay, the speed control mode, so we can see everything here also inside this struct. Okay, and now let's take a look on the ladder elements that we have to control and configure the VFD. So we can find the ladder elements here under COM VFD. Here are the elements. Let's start by first. Okay, let's start with let's say we want to load the configuration to the VFD, the configuration that we made in the grid. So we have two options to do it. If we want just to download the modified parameters, so we will take this option, VFD write modified, and the input will be which inverter I want to download the configuration. So let's say I will select, let's say in this case, VFD1. And the configuration name. The configuration name is configuration 1. So it can be also from a tag, or I can just write here configuration 1. Okay, and this is just a status. You can see here all the statuses, whether it was successful, and if not, what is the problem. Okay, this is how to write all the modified parameters that we configured here in the grid. So only these ones will be downloaded to the VFD. Okay, because let's say if someone made some change in the keypad and you don't want to overwrite the configuration that was done from the keypad, you just want to download the modified, you can do it via this block. If you want to download everything, the whole configuration, including even the one that you didn't change, then this can be done by 2 steps. Okay, so let's see how it's being done. Okay, so first what we need to do is we need to use the load configuration. When we download the application to the PLC, the configuration is being downloaded as a file into the flash memory of the PLC. No, not to the SD, but to the internal memory of the PLC. And first what we need to do is we need to load the file from a file to the struct. Okay, so you can see here these are all the parameters, so it will be loaded to the struct. So again, I just need to select the VFD, the file name, so I can, let's say, do the same here. And again, status. Once we loaded the file into the struct, now we want to write it to the VFD. So in this case, now we need to activate the write configuration. Okay, so we have here the option write configuration. So we just pick the VFD and that's it. So now, since we know that we loaded the configuration for VFD1 struct, writing the configuration will basically write all the data which is inside the struct into the VFD by Modbus communication, of course. Okay, let's see other blocks. Let's say that right now I want to read the configuration from the VFD. So once I will read it, I just need to select to which VFD I'm reading. So once I perform this read, then all the data will be inside the struct. Okay, so let's say you configured everything from the keypad, but you want to read it into the PLC and see what are the parameters. You can activate the read and see them in the grid. Let's say that now you want to save the configuration back to the file in the PLC. In this case, we have the block which is called store. Okay. So now I can just select the VFD, and what this block will do, it will take all the data in the struct and save it to the configuration file we have in the flash. So this is the way to load, write, read, and store. Now let's take a look if we want, let's say, to read or to write a single parameter. I don't want to write the whole configuration or the modified configuration. I want to write single parameter from the HMI. I want to give my operator the option to change the acceleration time. Okay, so for this case we have these two options, write parameter. We have direct and indirect. Okay, let's just take a look on the direct. So I will pick the write parameter direct. So I just need to choose the VFD. Let's say I want to change the acceleration, so I will pick the basic function group, and I want to pick the acceleration time. B is the value. Okay, so let's say this is the acceleration time that I'm going to enter from the HMI, and of course status, whether it was successful or not. So this is the way, let's say, to change one parameter in the drive. If I want to read from the drive one parameter, I can do the same. Let's say I will pick the read. Okay, I will just select here which parameter I want to read. Let's say I want to read the max frequency. Okay, so that's it. Once I will activate this block, I can read the parameter into the struct. Now let's see some control commands, which is more interesting. You can see here all these ones are the control commands. Let's start with probably the most common one, which will be run frequency. So this block is being used to set the frequency to the drive and start it. So input A is which VFD. So I will, let's say, select VFD 1. B is the frequency. So it can come from a tag. For example, I can say here frequency value. Okay, so here you can set the frequency. By the way, the frequency is in hundreds of hertz. So let's say for 100 hertz, it will be 10,000. And parameter input number C, input C is the direction, 0 for forward and 1 for reverse. Again, it can come from a tag. Let's say I want always to move forward. Okay, D will be status. So this block is for running the VFD. Let's take a look on the next one, which is, let's say, stop. So very simple, just a block, select the VFD you want to stop, and that's it. We have several types of stop. This stop, of course, is stopping according to the deceleration. And we have the stop emergency, which will stop, of course, will immediately disconnect the signal to the motor. But of course, as I mentioned, since of the inertia, probably the motor will rotate more a little bit. And if you want to stop immediately, we'll have to use a mechanical brake. Let's see some more options. So we have here the fault reset in case the drive goes into fault due to over voltage, over current, many kinds of faults. You will not be able to run the drive until you reset the fault. So this is the block to reset the fault. The only input is just to select which drive I want to reset the fault. Okay, next one will be stop jogging. Okay, so if I'm in jogging mode, you know what, let's see first the jog. So jog frequency. So here I will select the VFD, and here I will select the direction. Let's say I want to jog forward. Now, the jog acceleration, deceleration, and frequency are determined in the configuration. Again, it's not something that you are doing in the operation block. This is something that you determine here. I think here under the fast configuration, you can see here you can configure the jogging run frequency, the acceleration, and deceleration. So once you will activate the block to start jogging, it will jog according to the frequency, acceleration, deceleration determined in the configuration. And of course, the next one will be the stop jog, okay, which is probably very clear, just to select which one I want to stop jog. So we are left with the torque mode. Okay, we said that we can also control the drive by torque. So let's see what is the parameters for torque. So first we select which VFD we want to run as torque. Parameter B is the torque value, which can be from minus 100% to plus 100%. So this will be the torque value. And parameter C, which is the forward rotation frequency limit. We can limit the frequency. So let's say I want to use 50% torque, but I still want to limit it, let's say, to 20 hertz. Then I can set it like this. And also for the reverse. Let's say also for the reverse, I want to limit to 20 hertz. And the status. And the last one, last block, this will be the auto tune. As I mentioned, first time that we activate the VFD with the motor. First we need to enter the motor parameters, and later on we if we want, we can run auto-tune for better performance. So for auto-tune, again, I just need to select the VFD that I want to auto-tune, and in parameter B we can select, as we mentioned before, rotation auto-tuning, which means that the load is not connected, or static auto-tuning when the load is connected. That's it. These are the ladder blocks. Now let me open we provided basically two examples. One which is simple, which I will show it now. A very simple, a very nice demo for just showing how simple to just to move it, to start it, move it forward, reverse, see it in a live trend, the values, and of course also an example for changing a single parameter. So first let me just show you how the HMI looks like. So now I'm connected by VNC. So what we have here in this demo, we can write the modified parameters that we configured, start and stop, forward and reverse, status of the drive, changing frequency, trend, live trend, and changing acceleration, deceleration. So right now you cannot see my drive and motor, but still you can see if I will click here on start, you can see now that the drive went into forward running. You can see also what we are showing here is the voltage, current, and frequency. Okay, we can you can see, for example, if we look on the frequency, if I will change the frequency to 10 hertz, around 10 hertz, you can see how the green line went down. I can change also, let's put it on 40 hertz, for example, and I can change it to reverse. So you can see basically the VFD decelerates, change to reverse, and go back to the around 40 hertz. From here we can change the deceleration, acceleration, and I want to show you a really nice feature that we released also in this version. We call it the scope trace. So just let me open it here. So the scope trace is basically an option to view the tags values as a graph. Okay, it's not limited only to VFD. You can use any tag that you want from the system, not Boolean of course, but integer. And here, for example, you can see you can prepare up to 8 watches. I prepared here one watch, which with several tags like frequency, voltage, current, and you can define here minimum and maximum. You can define color, and you can define the factor. For example, here I set the factor to 0.01 because the frequency is in hundreds of hertz. And you can see here we have 3 icons. If I will click here, it will open it will go online automatically. And once it will go online, you will be able to see the graph. Okay, so now you can see this is built in Unilogic, really nice. So let's take a look on the features that we have here. Before that, I just want to show you here how can, let's say if I'm changing the frequency, you can see it here. Okay. So let's take a look on what features we have here. We have the option to, you can see that you can select which curve. This one moves, you can see the checkbox are changing. I can change the selected curve. I can, let's say, hide here only and show you, because here you can see all the 4 y-axes. I can hide, and I want to see only the frequency y-axis or show all of them. I can hide all but only the selected. Here under the option, you can, by the way, you can see here the current values. Okay, the mean recorded, max recorded. Okay, you can even let's say pause, go back. Okay, you have also the scroll bar. Let's go to a place, a nice place like this. And you can see here also you can zoom in and zoom out inside the x-axis. You have the option for pinning. So I can pin the pin time slice. So you can see when I mouse over, you can see the blue dot. So I want to see, okay, what was the value here, here, and here, and let's say here. And then when you will click on the play, you will get a table with the times and here the values on each one of the points. Really nice option. And in addition, once you are closing, once you close it, okay, you have the option also. The Unilogic saves this data also to a file. Here you can open and view the files that were saved. And using this one, this icon here, open history, let's say, let's open the one that we just recorded. So I just double click on it. And here it is. So also we can scroll and see the data. And we can also export it to Excel. So if I will export it to Excel, let's say I will save it on my desktop. Okay, I will save it to trace. Right, and let me just open it to show you how it looks like. Okay, so this is how the Excel looks like. So you have the time and the values for all the tags that we recorded. You can see that we have more sheets here, like sampling metadata will give you information of the number of tags, what was the first sampling time, what is the interval, and so on. The tags descriptions, and even each one of the tags has a separate sheet to show its values and time. Okay, so this was just a quick one about the trace, but it's a really useful feature. And yeah, this is the application that I just show you. I just want to show you how easy it's being done. So here you can see on Power Up Value, I'm enabling the communication and the periodic read for statuses. This is the block to write the modified parameters, which this is the button to write it. Here we have the option to run frequency when we are toggling the start and stop motor. So when we are toggling it on, it will start. Toggling it off, it will stop. And also changing the frequency according to the slider. And also the option to write a single parameter for the acceleration and deceleration. So here what we did it on a keeped entry complete. So you can see here under the acceleration numeric box, whenever tag entry is complete, this bit will be on, and then we will activate the writing the parameter to the drive if we want to change, let's say, the acceleration or deceleration. So this is a very simple and nice example for demo, and we have much more advanced application that demonstrate all the features, including touring, including working with the terminals and so on. Okay, so this is in general the webinar for today. So I would like to thank you all for joining the webinar. If there are more questions, you can always send us by email. And of course, we will perform more webinars about VFDs in the futures. So please stay tuned, and our marketing will inform. Thank you so much, and bye for now.